Good morning, students. As we move into quadratic equations and functions, which is chapter 9, we're going to be going over some things that you would have learned from Khan Academy from the assignment from last week, but we'll just go over some of them because these are things we're going to encounter a lot in your future classes, and it's good to make sure that we're really comfortable with all of it. So these are some of the words to know. Square root. We know that if b squared is equal to a, then b is the square root of a. Radical, this is actually just the little symbol that we use to indicate square root. Radicand is anything that's inside the radical, inside the square root. Okay, a perfect square. A perfect square is a number whose square root is an integer. A radical expression is any expression that involves a square root or a radical, basically. A quadratic equation is an equation that can be written in standard form of ax squared plus bx plus c is equal to 0, where a is not equal to 0 and a is the leading coefficient. We'll be working more with quadratic equations as we move further in the chapter. Example 1, evaluate the expressions. We're going to evaluate some radical expressions. We're looking at the square root of 81. You should all know, because 81 is a perfect square, that the square root of 81 is 9. The negative square root of 49, so we have a negative outside our radical, so we're actually going to evaluate the radical first and then apply that negative after. The square root of 49 is 7, and then I'm just going to have that little negative right before it. This plus or minus, so this means either the positive or negative square root, so I'm going to have two answers for this. So first, again, we're going to have square root of 16, which is 4. And then we're just putting that plus or minus here. The plus or minus really just means I'm looking at two numbers, positive 4 and negative 4. Square root of negative 1, it's important to note that you can never take the square root of a negative number. We can see this because positive 1 times positive 1 is equal to positive 1. Negative 1 times negative 1 is also equal to positive 1. So you'll notice that any two numbers multiplied together will never give you a negative, so there is no real square root. Okay, moving on. Example 2. Evaluate the square root of b squared minus 4ac when a is equal to negative 2, b is equal to negative 5, and c equals 2. So for this one, we're pulling into mind some of our concepts from earlier in algebra. One would be substitution, where my first step would be to substitute all my variables in, their values in for the variables. And the second step would be to follow PEMDAS to evaluate the expression. So first thing I'm going to do is substitute. Since b is negative 5, I'm going to put that negative 5 within parentheses in for b. So we have square root of negative 5 squared minus 4 times a, parentheses again, negative 2 times c, which is 2. So for this, we're going to use PEMDAS inside. This whole radical is considered a grouping symbol, so we can do everything inside. Negative 5 squared is going to be negative 5 times negative 5, which is 25. Then we have 4 times negative 2, negative 4 times negative 2, which is positive 8, times 2, which is positive 16. I like to interpret this 4 as a negative because so I don't get confused with signs later on. 25 plus 16 becomes 41. So I can either leave it as 41 or I can find the approximation, which is using a calculator, 6.40. We like to round to the hundredth place, which is the second decimal. Don't forget PEMDAS. Okay, example 3, we're writing before finding square roots. We're going to solve this. This is considered a quadratic equation. We have ax squared plus bx plus c. Basically, I have an equation that has the highest degree of my variable is x squared, and there's only one variable. So we're actually going to do this by rewriting this. So since I'm able to find square roots right now, I want to actually still do the same thing that we always do, which is to isolate x. We're going to do this firstly by following the same steps as usual. We have we're going to add 100, get rid of this 100. So we have 4x squared is equal to 100. And in order to get rid of this 4, I'm going to divide it out. Divide by 4, divide by 4. X squared is equal to 25. And when I'm doing a square, we always take the opposite operation. The opposite of addition, we did subtraction, we did addition. Multiplication, we divided. The opposite of square is taking the square root. But when we're taking the square root, in order to cancel out a square, we have to account for the negative also, because positive 5 times positive 5 is 25, but negative 5 times negative 5 is also 25. So there's going to be two answers for this. A good hint is that if you have x squared, it means you're mostly going to have two answers. So we have this square root cancels out the square, so we have x is equal to plus or minus square root of 25, which, when we evaluate, like we did earlier, square root of 25 is obviously 5, but we have to account for that plus or minus. So there I have two answers, positive 5 and negative 5. You can check it by subbing it back in. 4 times 5 squared. 5 squared is 25. 4 times 25 is 100. Minus 100 equals 0. It works also for negative 5. So we're going to do some review on simplifying radicals. I know you've worked with this before, but we'll just do a little bit more. So expression with radicals is in simplest form when these things are true. No perfect squares other than 1 are inside the radicand. No fractions are in the radicand. No radicals appear in the denominator of a fraction. So we're not dividing by radical ever. Okay? So we're going to keep in mind our product and quotient properties of radicals, or square roots. So if we have the square root of AB, we can actually split this up into square root of A times square root of B. And then, of course, we can go the other way also when A and B are positive numbers. Quotient property, square root of A over B is equal to the square root of A divided by the square root of B, when A and B are positive integers, or positive numbers. Simplify the expression. So whenever we're simplifying an expression using the product rule, we want to split it up so that we have a perfect square and whatever extra there is in there. So 147 is actually divisible by the perfect square 49. So 147 is actually 49 times 3. Using this, I can split it up into two different radicals, square root of 49 times square root of 3. And square root of 49 we know is 7. We're going to multiply by square root of 3. And that is the simplest form of square root of 147. Same thing for 300. So anything that ends in 2 zeros, I know is divisible by 100. So I can actually factor out 100 because that's a perfect square. So we're left with 100 times 3. Okay, we split up into two different radicals. Square root of 100 times square root of 3. Square root of 100 I know is 10. Square root of 3. Simplifying now with the quotient property. So square root of 63 divided by 6. So I'm actually just going to simplify this numerator. So my radical is only for whatever number is in my numerator. So square root of 63. 63 is not a perfect square, so I'm going to break it up. 63 is divisible by the perfect square 9. So I'm actually going to do this, where we have square root of 9 times 7 over 6. I'm leaving that over 6. Equals square root of 9 times square root of 7 divided by 6. Square root of 9 we know is 3. So we have 3 root 7 divided by 6. We're actually going to simplify this fraction right here, right? Where this is going to become 1 and this becomes 2. So we're left with square root of 7 divided by 2. For this next one, letter B, square root of 11 over 4. So we have a fraction inside our radical. We're going to split this up into two different radicals. Square root of 11 divided by square root of 4. We know the square root of 4 is 2, so we have square root of 11 over 2. As long as I have no radicals in my denominator, then I'm good.